I'm going to look at section 1.2, functions and their properties. The first thing we need to do is figure out whether something is a function or not. The way we can do that is either algebraically, because an equation is a function if for every x there is one answer for y. So a lot of times we can just look at the equation that they give us and figure out, am I going to get one answer or am I going to get more than one? That'll tell us if it's a function or not. The other thing that we can do is if we have a graph, then an equation is a function if it passes the vertical line test. Okay, so we're going to look at a couple of examples of each of those. So starting out with algebraically, on this first example, they give us y equals the square root of 3 plus 4x. And we need to figure out, is that a function or not? And what I'm going to do is I'm going to think about that and say, if I plug in something for x, how many answers will I get for y? Well, if I'm not sure, I can actually go ahead and sit here and plug something in just to test it out. If I, want to plug in 1, then I can write it out, plug in 1, and say, all right, 4 times 1 is 4, plus 3 is 7. The square root of that I'm just going to leave as square root of 7. So I would say, how many answers is that? That's one answer, the square root of 7. And any number that I put in, that's going to work the exact same way and give me one answer. So that would mean that, yes, this is a function. Okay, on this bottom one, what we have is x equals y to the 4th. And so this one, hopefully we notice, like right off the bat, that it's going to be a little different because we have y to the 4th power here, meaning it's not solved for y already. So that's going to make this a little bit weird. But let's think about if I plug in 1 for x on this, then what does y have to be in order for us to take it to the 4th power and get 1? Well, we can put a 1 in here. 1 to the 4th power is 1, but because it's an even power, we also need to think about that if I put a negative 1 in here and I say negative 1 to the 4th power, that means that would equal 1 as well. So you see how I got two things for y here whenever x was 1? Two answers, 1 and negative 1. That means that this is not a function. Let's look at graphically now using the vertical line test. I have this graph over on the right side here that I want to know, is this a function? So I need to think about, if I drew a vertical line anywhere on this graph, how many times is that vertical line going to go through my graph? Well, it only goes through once. No matter where I draw that line, it's only going to go through my graph once. That means that it does pass the vertical line test, and since it passes it, it is a function. An example of something that would not pass the vertical line test would be something that goes back and forth like this. Okay, where if I draw a vertical line, then that doesn't pass the test. It goes through more than once, so that would not be a function. Okay, now let's look at domain and range. Domain is the x values for which a function is defined. Range is the y values for which a function is defined. And so what we find is that for a normal equation that doesn't have any fractions or square roots in it, your domain is going to be negative infinity to positive infinity, because any number is going to work. The things that cause problems when we're plugging in numbers for x are if we have a fraction with an x on the bottom, x can't be 0 on the bottom, so that gives us a place that our domain doesn't reach. Or if we have a square root, then anything that would give us a negative under our square root would not be in the domain. So let's look at an example of each of these. Okay, for domain up here on the top, it asks us to find the domain. We have a fraction, so what I'm going to do is set the bottom of that fraction equal to 0, because any place where the bottom equals 0, that is a place that is not in my domain. So if I already have two factors, they were nice and they factored it for us for this problem. So I need to say, well, x plus 7 equals 0 and x minus 4 equals 0. What does x equal? And if you can do this in your head, that's fine. You don't have to write it out. X would equal -7 and x would equal 4. So those are the two numbers that when I plug in on the bottom give me zeros. So what I need to say in my domain is all of the numbers are fine except for -7 and 4. So I'm going to write it in interval notation where I'm going to say from -infinity to my farthest left number, which is -7, I can plug in all of those numbers, but I can't plug in -7, so I make it a parentheses. Then I can go from -7 to my other number, which is 4. But again, it can't equal either one of them, which is why I'm putting parentheses, not brackets. And then I can go from 4 to infinity. Okay, that's my domain. It looks really long, but all we were really saying is that -7 and +4 are not included. On the range, what's usually easiest to do on the range is to look at the graph, but sometimes it can help if we know the properties involved in an equation. Like, in order to graph this by hand, I would say I know that it's a parabola because it's x squared, and it's going to be a parabola opening up that starts at -3. It's been shifted down to -3 and then it goes up. Well, because I knew that already, I could have probably written my range before I even started. But now that I have my graph, I'm looking at my range starts right here at -3, and then I have y values going up to infinity. So that's what I need to write, is my range is -3, and it can be -3. So that's why I have a bracket, and then it goes to positive infinity. So that's my range. On domain and range, you can graph in order to figure out what the domain and the range are. You can look at it, but sometimes it's just as easy just to work it out by hand, depending on your opinion. Okay, this is the end of the first part of my video.